Hello, discrete math fans. So now let's go through the Euclidean algorithm. Now this is just repeated applications of the lemma that we just proved, and then using the quotient remainder theorem. So as an example, let's illustrate the Euclidean algorithm by computing GCD of 210 and 45 by hand. What we want to do is divide 210 by 45 to get a quotient and a remainder. Now, in the theorem, it didn't tell us how to compute the r. It didn't say that it had to be a remainder. It just had to be some r that satisfied the equation that we were using. But the quotient remainder theorem is the most efficient way of doing this. All right, so if we do the long division and do 45 divided into 210, all right, I'm not going to go through the gory details. We get 4 as an answer and a remainder of 30. So 4 is the quotient and 30 is the remainder. Now what that tells us is that 210 is equal to 45 times 4 plus a remainder of 30. And our main lemma now tells us that the GCD of 210 and 45 is equal to the GCD of 45 and 30. So the Euclidean algorithm is a reduction algorithm. It doesn't give us the answer right off. It tells us how to reduce the numbers. So we're going to keep doing this until the numbers get down to something that is a little bit more manageable. Now obviously at this point we might be able to quit and just say what the answer is, but let's take the Euclidean algorithm all the way to the bitter end. Now we're going to continue. We'll divide 45 by 30. Again, we get an answer of 1 and a remainder of 15. All right, that's getting close. This is telling us that 45 is equal to 30 times 1 plus 15. And now our main lemma tells us that the GCD of 45 and 30 is equal to the GCD of 30 and 15. All right, maybe you can look at this and see the answer. Let's keep going. One more division. So now, if we take 15 and divide into 30, we're going to get an answer of 2 and a remainder of 0. Aha! So our main lemma tells us that the GCD of 30 and 15 is equal to the GCD of 15 and 0. Now, no more divisions because we ended up with a 0 and we can't divide by 0. Now we're going to appeal to our first lemma. That was the technical lemma that we started with. That tells us that the GCD of 15 and 0 is 15. So the main idea here is that we can stop as soon as we reach a division that doesn't have a remainder. Now let's sum up the entire process that we put together. We started with the GCD of 210 and 45, reduced that to the GCD of 45 and 30, reduced that to the GCD of 30 and 15, then to the GCD of 15 and 0. Those 3 steps were all done using the quotient remainder theorem and getting a remainder and replacing things. And then the final step is done with our technical lemma, that tells us that if we take the GCD of a natural number and 0, well, we're just going to get that natural number as an answer. All right, so that's our final answer. The GCD of 210 and 45 is 15. And naturally, this probably could have been done much more easily by just factoring 210 and 45. But again, remember that this idea is done in such a way that we don't have to factor. We're just doing division. Division is a much more efficient process than factoring. Okay, that's all for now.